So question 5 reads, find the reference angle for the given angles. Now the issue of reference is a very critical issue in this course. So we have 4 quadrants, and each quadrant has got its own set of the reference angles. All the angles that lie in the first quadrant are reference angles of themselves. The angle that lie in the second quadrant gives us a reference angle by subtracting those angles from 180. The angles that lie in the third quadrant gives us a reference by subtracting 180 from those angles. And the angle that lie in the fourth quadrant gives us a reference angle by subtracting from 360 those angles. So in a case of A, where we have A is 225, then we are looking for a reference angle of 225. Our question is, where do we find 225? So we know the first quadrant runs from 0 to 90, second from 90 to 180, third from 180 to 270, and fourth from 270 to 360. So is 225 between 180 and 270? Of course, yes. So its reference angle is going to be 225 minus 180, giving us 45 degrees. For B, the angle given is negative 35. Now, since we did question 4, we were able to get a positive coterminal angle of 35, of negative 35. And that coterminal angle lies between 0 and 360. As you can see that this quadrant here has been defined from 0 to 360. And so the issue of reference angle that we have talked about has been talked about within 0 to 360. So if I'm given negative 35, what I'll do is I'll add 360 to it so that I get its coterminal angle. And this will give us 325. 325 falls in the fourth quadrant. So what then do we do? We'll say theta, which is the reference angle, is the same as 360 minus 325. So this is a special quadrant, because it will just give us a positive of it in that manner. Okay, unless we have questions here, we still have these reference angles in question 6. So prefer moving to question 6. And this is a question. Okay, no question. So we go to question 6. Question 6, find the exact values of the given trig ratios A, tan negative pi over 6. We want to get this value here. Now for tan, we say that in each quadrant here, each trig ratio is positive twice and negative twice. So tan, in terms of being even and odd, even functions, we have cos, we have sec. Odd functions, we have sine, we have cosec. And so we'll have tan, we also have cot under the odd set, meaning that this here being characterized as an odd function, we can either decide to just pull the negative outside and remain with this. Pi over 6 is 30. So what is tan 30? What is tan 30? So you have got several ways of obtaining the angle. You can get using the triangles. If you've forgotten the triangles, using the table. So we know that this is going to be half over 3 over 2, meaning it's negative 1 over 3. Okay. B.
Sir,
Hello.
what are we finding the difference angle trig ratio?
We are finding the exact value of the trig ratio. Is this
Okay, I
the?
thought maybe we're still on.
No, we have moved on. We are quick to move on. Okay, so sine 7 pi over 6. What's 7 pi over 6? If you can't figure out the angles, you convert them to degrees. So I can't figure out, I'll convert to degrees. I'll get this guy here 1, this guy here 3. So that is 210. 210 is in there. So it's like we are dealing with sine 210. And 210 is in the third quadrant. So we can get its equal by subtracting this. And then we are getting 30. So it's like a dealing with sine 30. Except that because it's in the third quadrant where sine is negative, we're dealing with negative sine 30. And so negative sine 30 is just negative half. So because each quadrant carries a sign, and look at the angle given, you switch to issues of signs. Okay, we can as well do.
Sir,
Yes.
on if someone said we should be rationalizing the answer. So like that, is it just okay?
Yeah. The question has not said anything about the rationalizing, so it's just okay. It's just a value. And there's no harm in rationalizing. Just like there's no harm in not rationalizing. As far as angles are concerned. Okay, what about cosec 90? Cosec 90 is 1 over sine 90. but sin 90 is 1. So we'll get 1. Very, very easy. Okay, it looks like this question has become too easy. So let's move to question 7. Question 7, find the trig ratios of the other 5 trigonometric functions given that cos theta is equal to 8/17. Now, this information is not sufficient enough for us to be able to get the required other trig ratios. So they have also given us sin theta to be negative. So what does it mean? It means now we're looking for a quadrant where cos is positive and sine is negative. And that quadrant is the 4th quadrant. So you go to the 4th quadrant and form a triangle attached to the x-axis. So this is the theta we're talking about. Now cos, as we know, cos is from SOHCAHTOA. Cos is adjacent over hypotenuse. So this means that this 8 we are seeing there is adjacent, and this is hypotenuse. So now we need to find the other side. So do 17 squared minus 8 squared and then square root the figure we get. Someone to do it for us. What's the solution?
It's 15.
15. Good. So this is 15 here. And then now, since we already have a cos, we can start with the same sign. Now this 15 is on y, so it must be negative. So it will be negative 15. And then we start with sine. Sine theta is opposite over hypotenuse. So opposite is negative 15. Hypotenuse is 17. We can get cosec just here. Since cosec is 1 over sine, then it's going to be negative 17/15. Then we can go to sec. Since sec is 1 over cos, then to be 17/8 since cos is already given. Then you can go to tan. Since tan is opposite over adjacent, we'll have negative 15/8. And then we'll go to cot. Cot is just switching this on this one. So this was A. I can allow any one of us to pick the question that they tried and they had headache. Anyone to pick the question of their choice. Okay, no choice. So we're okay with this part then.
Question E.
E.
Yes.
Okay. Let me look for E. Where is E? E cosec theta is equal to 2. And theta in quadrant 1. And theta in first quadrant. So in the first quadrant, we draw a triangle here. Like that. Now, when I'm given cosec, the easiest guy to think of is sine. Okay.
Which one is the answer for question A?
We have 5 answers to question A. Sine, cosec, sec, tan, cot. So even here, I'm going to have 5 answers. So this is our theta.
So I can see a lot of sine what, cos what. Which one is the exactly answer?
All of them. You didn't read the question. The question says, find the trig ratios of the other 5 trig functions, given one. So all the 5 are the solution.
All right, sir.
Okay.
Thanks.
So if I'm given cosec, I know that cosec theta is 1 over sine. So I can switch them and get that sine theta is 1 over cosec. Now, since cosec is given as 2, then I'm doing 1 over 2, where 2 for sine, 2 is the hypotenuse because it's opposite of hypotenuse. And then the opposite is 1. So we're looking for the adjacent. So adjacent is going to be 2 squared minus 1 squared, and then you square root. So we're going to get 4 minus 1, which is 3. So this is going to be root 3. And then once I have that root 3 there, what do we have? We have cosec. So you can easily find sine. We have already found sine anyway. It's 1 over 2. And then we go to cos. Cos is adjacent of hypotenuse. So adjacent is root 3. And hypotenuse is 2. Then we go to sec, which is 2 over root 3. Then we go to tan. Wow. Tan is just opposite of adjacent. Opposite is 1. Adjacent is root 3. Cot is 1 over tan, so it's root 3 over 1. Again, we have 1, 2, 3, 4, 5. The question is done. Exactly. You understand this question, huh? This is the truth.
Thank you. We can move on.
That's fine. Okay, let's go to question 8. Question 8. Use or verify. Hello?
We're not supposed to go to question 7.
Oh, but we are on question 7. This was question 7. Okay. Question 8, verify the following identities. A Sine theta cot theta is equal to cos theta. So we get the left-hand side, which looks like it can be simplified and say, okay, sine theta cot theta. This guy is the same as sine theta multiplied by cot can be written as cos theta over sine theta. And for sure, this is cos theta because the sine and the sine will cancel. Okay. B cos theta sec theta over tan theta is equal to cot theta. Then we again pick the left-hand side. So you pick the side which looks simplifiable, because if you take cot, you can't make it to be this complicated thing on the left. So prefer getting what is complicated, because when we do something to it, it will give us a simplified one. So this is going to be cos theta multiplied by 1 over cos theta over tan theta, giving us cos over cos is 1. So we have 1 over tan theta, and this is exactly what is called cot. So identities are very, very easy, for long as you know how to switch from tan, cot, sec, cosec to sine, cos, then you are done. At your own choice, you can solve another one. Who's choosing?
Sir, F. F, sir.
F, where is F? Okay. F. Sin X.
Excuse me, sir.
Hello.
There on question B, where there is tan down, can you simplify it to sine over cos?
Yes, you can do that. And then since it's in the denominator, you do the denominator switching, then you get cot.
Okay, sir.
So this squared over sine squared x minus cos squared x is equal to sine squared x minus cos squared x over sin x minus cos x squared. It's funny. There's nothing like this part is complicated than the other. Okay. Then which side do we pick now? Exactly. Okay, let's pick the left-hand side. It will guide us since they look like they are all complicated. So if we start with this side, we'll have sin x plus cos x squared as it is, and then the denominator, we do difference of two squares, we'll get sin x minus cos x and sin x plus cos x. And then we'll see that the square will be taken care of by this piece here. So we remain with sin x plus cos x and divide by sin x minus cos x. But because of the right hand side, the denominator here needs to be squared. So meaning that we need to come back and multiply by sin x minus cos x and do the same in the numerator to avoid changing anything. We multiply also by sin x minus cos x. But the arrangement of the numerator shows that that's a difference of two squares. So that's sin squared x minus cos squared x. And down here, the sin x minus cos x is squared because you're multiplying it by itself. And this is what we have as a right hand side. Done.
Kindly repeat, sir.
So the first thing we've done on the left is going to the denominator and factorize it as a difference of two squares. So if I have two things squared, I can do sine minus cos, sine plus cos. Now sine plus cos is sine plus cos also on top, except that the top one is squared. So one of this the square things, one of them will cancel the denominator. So one will remain. Now if we check our right hand side, it requires that our denominator here, which we have, which is sin x minus cos, be squared. The only way it gets a square is when you multiply it by itself. But then you can't just multiply anything by a denominator without touching the numerator, because you'd have changed the question. So you also multiply by the same thing in the numerator. Now, because we have two things down here multiplying by itself, we're going to have it squared, and then we expand the numerator. If you expand the numerator, it will give us the difference of two squares because it's sitting in the difference of two squares format. And so this becomes a solution for this part. An easy proof, which look so complicated. Okay, so this is a due ceiling question 8. The identities, you can't solve all of them. There are so many identities in this one. You solve one or two and do others when you're alone. When you're alone. Okay, so Zoom setup. We have a minute in case you have questions. You can ask. When we log out and log back, we'll be on question 9. So I finished this tutorial sheet just so. This is a good thing. How many tutorial sheets do you have altogether?
Si anafika 13.
Already.
Sir.
18.
13. And we are on 8. And today it will be finished. Then again on Friday, do another one. Finish it. They'll all be finished.
Sir. Sir, there where there is a denominator, sin x minus cos x.
We multiplied by sin x minus cos x again.
And then if we are supposed to multiply the weight. But why?
But why what?
Why has it multiplied itself? The denominator which is down.
Because wanted it to be squared. So multiply by itself and then multiply by the same self on top.
What do we